Hello again. Welcome back. This is domain and range part 2, part 2. And this part we're going to talk about how we can tell something about the domain of a function by looking at instead of looking at the graph like we did in the last video, we're going to look at the function itself, like the algebra of it, and see what that tells us about the domain. This is going to be something that you're going to be asked to do a lot in the future. So paying attention would probably be a good idea. So what can we tell about the domain of a function of looking at the algebraic form? So this is a function, f of x equals 1 over x, or you could say y equals 1 over x. They have the same meaning. When we're talking, this is for coordinate axes. This is for just anything. And the question about the domain is always, remember, this is about x values or inputs. And the question is, what x's can we put in here? And the answer is most of them. It turns out there's only one x that doesn't work in this function, and that's 0. You cannot have 1 over 0 because it's undefined. You can't divide by 0. So the only x that doesn't work in this one is x equals 0. So we'd say something like x cannot be 0. And for a function like this, it's a similar thing. You have this x on the bottom. And now I'm like, what I don't want is for x minus 2 to be 0. So the question really is, what x makes x minus 2 equal to 0? And the answer is x equals 2. You can kind of figure that out by setting this equal to 0. You can say, well, let's try that. If x minus 2 equals 0, maybe add 2 to both sides, and this gives you x equals 2. So really, this means x doesn't equal 2. Like, the answer to this, what's the domain of this function, is all the x's except 2. So like, how can I, like, this is not really inequality notation or interval notation. And the question is there a way to write this in inequality and interval notation? And the answer is yes. And to me, the easiest way to picture this is to picture a number line first. So here's a number line. There's 0. And like, I don't want 0 as part of my set. Like, I want this number line, what I want on there is all the x's that work. So all the negative x's work up to 0. But 0 doesn't, and all the x's after 0 or bigger than 0 work, but not 0. And so what this number line is going to look like is like this. It's going to be like all the negative numbers and all the positive numbers, but this circle, this open circle over 0 tells me that I don't want 0. So you can kind of translate this directly into interval notation, or let's do inequalities first. So it's just, you have to split it up into 2 pieces, because there's this piece here, all the negative numbers, and then this piece here, which is all the positive numbers. And the way to write all the x's that are less than 0, which is what this is just to write that. All the x less than 0. This blue piece here is x less than 0, all the negative x's. And this blue piece here is all the x's that are bigger than 0. And then between these, we're going to put an or. Because basically what we're saying is, what x's work in here? Well, either x's that are less than 0 or x's that are greater than 0. And it's important to notice that this encompasses all the x's except 0. The only number that's not represented in this little statement here is 0, and that's what I wanted. I wanted all the x's except for 0. And I can do a similar thing with interval notation. I can look at this blue interval here on the left and say, well, what's the left endpoint? What's the left side of this interval? And the answer is, well, it goes on forever to the left. And we learned earlier that that means negative infinity. And the right side of this interval is 0. But I got to use a parentheses because you can see the open circle means the 0 is not included. And that, again, you can kind of connect this strictly less than sign here with this parentheses. And then in a similar fashion, I look at the right side of this and I say, the left endpoint of this interval is 0. And the right endpoint, the right side, well, there is no right side. It goes on to infinity forever. So I just write another infinity. Infinities always get a parentheses. And I want to put a parentheses here because the endpoint 0 is not included. And the last mathematical number that we need, or mathematical symbol we need, is this U. It's like a kind of a U. It's a U. It means union. It means like this set and also this set. It means the same thing as this. So this means all the x's from negative infinity to 0 and all the infinities from all the x's from 0 to infinity. But I kind of, this parentheses U parentheses is a way to remove that one value. That one value is not counted. Because this means all the way up to 0, but not 0. And this means all the way, this means everything from 0, but not counting 0. So using the exact same logic for this second one, I could say, well, if I want x to not be 2, the picture would look exactly like this first picture, except there'd be a 2 up here instead of a 0. Which means that in interval notation, it would look like, or sorry, inequality would look like x is less than 2 or x is greater than 2. The interval notation would be like negative infinity to 2, and then 2 to infinity. So this is like 2 ways to write these intervals, inequalities and interval notation, 2 ways to write these sets. And you just got to kind of pay attention to what the endpoints are. My experience with students is that when they have to do these x's where it's not in between two numbers, where one of them is an infinity, it gets a little confusing. Some people are like, I don't like that this is less than and that's greater than. I mean, okay, I get that. You can write 0 is less than x if you want to write this that other way, but this feels weird to me. I like to have the x on the left side, but that's just a personal preference. Now the last one here, this square root, you may or may not remember that when we're talking about real numbers, which we are when we talk about the coordinate plane, when I ask about the domain, I'm going to be asking about the domain of all the real numbers that work. And the square root, we know that we can't do this. Like that's not something that we want to think about right now. We don't want to think about the square root of negative 1. Some of you may know that that's very possible to take the square root of a negative number. But like we don't want those in here. A question I usually ask students when we go over this is, can you take the square root of 0? And the answer to that is yes. The square root of 0 is equal to 0. So basically what I want, the x's that work in here, are all the x's that are bigger than 0. Sorry, all x's, let's say it this way, all x's that are not negative. Zero is not negative, and all the positive numbers work. I can take the square root of any positive number I want. You're welcome to try in your calculator if you want to, but the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3, and so on and so forth. So basically the x's that I want are the ones that are not negative. That means like if I want to think about the number line idea again, that's 0. I want all of these numbers up here. But this time, unlike before, I actually want 0. I want a filled in dot there. So I want all the positive x's and I want 0. So in inequality notation, this would look like all the x's that are greater than or equal to 0. In interval notation, they can look at this little blue line and say, well, the left side is 0 and the right side, well, there is no right side. But there is. The right side, we would say infinity. That means it just gets as big as you want it to get. The infinity always gets a parentheses. And this filled in dot on 0 means that I do a bracket there. So this is the domain of f of x equals root x. It's all the x's from 0 to infinity, including 0. So basically all non-negative numbers or something like that. So basically, there's 2 things that we look at when we talk about the domain of a function from its algebraic form. We look at all the stuff that I just did is all explained right here. That's cool. We look at if there's an x on the bottom, that's usually going to cause a problem in the domain. And if there's a square root, that's usually going to cause a problem, a restriction on the domain. It's going to cause us to not be able to use some values of x. Here, we couldn't use the x's that made for these two. You got to say, I want the bottom can't be 0. The denominator of this fraction can't be 0. And for these ones, the things under the square root, that has a name, which I'm not going to say right now. Things under the radical, that's the name of the square root symbol, have to be positive. So like those are kind of our two restrictions right now. Things on the bottom can't be 0. Things under square roots can't be negative. Have to be positive. Have to be positive isn't right because it could be 0. So have to be positive or 0. And that's why I could use this equal sign here. So we're going to see this. I'm going to sketch through these just so we can kind of see. Again, we just did this. Square root of x, we said from 0 to infinity, and that looked like this, 0 to infinity. And in inequality notation, it looks like that. And the 1 over x, we were like, well, the only x that doesn't work is 0. And so we imagine I want all of these, not that one, and all of these. We decided that this piece was like all the x's that are less than 0. This piece is all the x's that are bigger than 0. And with inequalities, you put an or in between them. And for interval notation, we say this is all the x's from negative infinity to 0, all the x's from 0 to infinity. We put a u. The u kind of corresponds to the or. And these parentheses here on the inside by the zeros correspond to the fact that this is not less than or equal to, and this is not greater than or equal to. And very similarly, very much in the same way, this one looks something like this, where now it's 2 that I'm taking out. And so I end up with x less than 2 or x greater than 2. And then all the x's from negative infinity to 2 combined with all the x's from 2 to infinity. I think it's important, or it's helpful to think about that what this piece in here does, the 2 parentheses union parentheses 2, this removes 2 from our collection of x values. I'm going to rewrite the word from because it looks like a 2-year-old wrote it. Try that again. Removes x from our collection of x values. So that's like how we get rid of a value if we don't want it. All right, and this page has it's the same idea, but it's like more, it's a little more complicated, but we can approach it in very much the same way. There's 2 separate pieces here, which means I'm going to have an or I'm going to have a u, because I can't write this as one piece. So I'm going to write each piece separately, then I'm going to put the word or between them, or I'm going to put a u in between them. So if I start with this left-hand piece, this is all the x's from negative infinity all the way up to 10. Or you can think of it as all the x's that are less than 10, including 10. So all the x's that are less than 10, including 10. That equal sign means I get to choose 10. And this piece is all the x's that are bigger than 15, but not including 15. So x bigger than 15, not including means I don't put the equal sign. I put the word or between them to indicate it's either this one or that one. And from a point of view of interval notation, I would write this one by looking at the left and right-hand sides of this one, and then the left and right-hand sides of this one, and putting a u in between those 2 sets. So this one, the left-hand side there is no left-hand side, which means it's negative infinity. And the right-hand side is 10. And I want to bracket because there's a filled in dot. Filled in dot means a bracket, means an equal sign. Those things are all connected. Boom, 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 every time. The second piece, which was x is greater than 15, the left-hand side is 15. The right-hand side is, oh, there is no right-hand side. That means it's infinity, goes on forever. Infinities always get in parentheses. And now this one, because it's an open circle and there was a greater than, but no equals, gets in parentheses, and I put this kind of fancy U in between them. And that's how you write that set in interval notation. So we will do, obviously, maybe not obviously, but I'm telling you right now, we will do more practice with these in class. The point here was to get you familiar with the notation and the difference between greater than or equals, and to introduce you to what the brackets and parentheses mean in interval notation. So hopefully you got something out of this, and we'll see you in class.